these two examples where we're looking at 4-digit codes. And it's very important to notice that whether they can be repeated or if they must be different. So think about 4-digit codes. That means that the numbers can be anywhere from 0, 1, 2, 3, all the way up to 9. Think about it, we cannot include the number 10 because 10 is a 2-digit number. And so if you count the numbers between 0 and 9, there are a total of 10 numbers. Because 1 through 9 is 9 numbers, 0 counts as a 10th number. So if we look at a 4-digit number, so 1, 2, 3, 4, and we can start it with 0, so any of these places right here can be 0 through 9, and we can repeat. So it doesn't matter what number this is, that same number can be here. So I can have all 9s, or I can have all 4s, or it can be all 0s, or they can all be different. And I want to know how many different numbers there are. Well, that means that in this place, I have 10 different numbers to select from. And if it doesn't matter what number I get there, in this place, I also have 10 different numbers to select from. And I have 10 different numbers to select from here. And I have 10 different numbers to select from here. So if I have 10 numbers to select from here, and 10 different numbers to select from here, and 10 numbers here, and 10 numbers here, in order to get how many different numbers we have, we're going to multiply these. Fundamental counting rule, we multiply through. So we're going to have 10 times 10 times 10 times 10. So if we can repeat the values, we're going to have 10,000 different 4-digit numbers. That is, with repeating. Now, if they must be different, so I've got 4-digit number, they must be different. So the first digit, I have 10 numbers to select from. And let's say that I select a 5. So that means in my numbers to select from, I have the numbers of 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. I selected the number 5. So for the second place, I no longer have 10 digits to select from. Because I've selected the 5 and they must all be different, I now only have 9 digits to select from. And let's say for my second digit, I select the 6. So I mark out the 6. Now I've taken away 2 digits, so now I only have 8 numbers to select from. And let's say that I select the 0. So for my last digit, I only have 7 numbers to select from. So whenever they must be different or without repetition, I must knock down a number each time for each of my slots because I no longer have this value to select from each time. And then we multiply those. And so 10 times 9 times 8 times 7 would only give me 5,040 choices to select from. So there's a huge difference as to whether numbers can be repeated or if they must be different. If they can be repeated, it's the same number of choices for each selection. If they must be different, I have to knock it down 1 for each of my slots. If you randomly assign an employee a 4-digit number that can start with 0 and have repeats, so we're talking about this incident right here, then what is the probability that all of the digits are even? So if we're talking about this incident right here, where they can be repeated, this is how many total possibilities there are. So this right here becomes my denominator. Think about probability. Your denominator is your total number possible. So my probability, my denominator, is going to be that 10,000. How many total possibilities do I have? But we want that all the digits are even. So let's think about all 4 digits being even. And we can have repeats. So let's think about our numbers being even. The even numbers are 2, 4, 6, and 8. Remember, 0 is neither even or odd. So we have only 4 numbers that are even. So that would be 4, 4, 4, and 4, which would give me 256 possible 4-digit numbers where all the digits are even. So my probability would be 256 divided by 10,000, which would be a 0.0256. And we would do example 12 in the exact same way. We have a 4-digit code, and it doesn't tell us whether things can be repeated or not, but if we're talking about opening a garage code, things can be repeated. So that would be 10,000. And if we want them to open it on the first try, that means he gets one shot out of the 10,000, which would be 0.0001, which if you put that in your calculator, a lot of you are going to get this 1e to the negative 4. What this e to the negative 4 means is this is scientific notation, and this e to the negative 4 is telling you to take this decimal and move it 4 places to the left. And so then you would put zeros, and so you'd have 0.0001, which is what I have here. Okay? If you have any other questions, just let me know. This is examples 11 and 12 from section 9.4.